Okay, thank you very much to everybody who have been on the line this whole time. As it says on the screen, there was a slight administrative hiccup, and I, Craig Buckingham, take full responsibility for that. So thank you very much for holding the line if you have, and welcome to those that are just joining us for the start of this presentation now. So Paul and Eric are both on the line at the same time, so if you could just kindly both unmute yourself and just say hello to everyone for me.
Good morning and good afternoon all.
Good morning everyone, Eric here.
There we go. So I'm not doing much. I'm just your hostess with the mostess, just to set the call up. The call is being recorded as per the other sessions. So those of you that are registered for this and are credential holders will get your CEC awarded for this session after the fact. If people happen to not be able to attend today's session, the video will be made available on the BICSI website for members to access after today or a few days down the track. All I'd say is if you have any questions as the session progresses, please feel free to drop them into the questions window. If I think they're relevant to what Eric is saying at that particular time, I'll just unmute myself and butt in and ask that question on your behalf. And if not, maybe we'll just stack them up to the end for the Q&A session. But do feel free to ask those questions, and I'm sure if they don't necessarily get answered today, they will do afterwards with Eric. So what I'm going to do now, Paul, you are already a presenter, I believe, so you should be able to do what you need to do from your side. So I'm going to mute myself for now, and I'll just be waiting in the wings. And once you're done, Paul, just give me the shout, and I will hand the presentation over to Eric.
Okay, thanks very much for that, Craig. I'm assuming everyone can see that opening slide with a little note about the adjustment to our timing. Apologies for that. It's just a little bit of a slight mix-up, and we thought perhaps prudent to just postpone it for 30 minutes just to make sure that all those who had registered would be able to participate and not miss any of the presentation. I'm going to speak as little as possible, about 5 or 10 minutes or so, just to give everyone a bit of a heads up about our program, just moving forward. So just a bit of housekeeping first of all, as Craig mentioned, if you could direct your questions, comments, etc. to the webinar moderator, that's Craig, via the chat box. You'll see that on your screen. So we can do that. We'll address those progressively and ensure that the questions are flagged and sent across to Eric, and Eric will be able to respond from there. We'll have a bit of Q&A time allocated at the end of the webinar, so your questions, pop them up when you have the thoughts come into your mind, and then we'll aggregate those and run them at the end. And as Craig also mentioned, CECs, we're just going to be going through the process of the application for CEC. So importantly, you being registered, if you're a credential holder, means that we can get this process sorted for you. Okay, today's program, as you've seen the last couple of sessions or webinars that we've had, we have a single presentation rather than multiple. Means that we consume less of your day, but you still get access to some very valuable information. I'm delighted to have Eric Lalaurie presenting for us on 5G. As many of you recall, Eric's presentation at the 2018 conference in Brisbane was standout to just debunk all the misunderstandings of Wi-Fi to give us the reality. Eric is a wireless expert, so he spent a lot of time in the RF space. He's done a lot of research into the 5G environment, and he's going to probe us with the thought, is it a revolution or is it simply evolution? So we look forward to listening to that material. Just a quick recap of some of the activities with our web seminars or webinars, whatever you'd like to call them. As you can see, we've had 4 so far. These have all been recorded and are now all posted on the bicsi.com.au website. You'll see the web link there. If you do need some information on some of the links that we've got here today, feel free to give me a call or drop me a line on email at the BICSI office. We'll be able to give you all the links to the specific information. Today's presentation, 5G, and then we've got 3 more which take us to the end of the fiscal year, the end of June. Beyond that, we're not sure. As much as I would like to say we're going to go back to physical physical seminars, we don't know. We're just in the hands of our government regulators in terms of helping us to beat the coronavirus situation. We may end up continuing, and from current accounts, since that's really only 6 weeks away, our expectation is that we'll continue to run these webinars going into July. and we'll keep you updated on that progressively. We are closely monitoring what we are and are not allowed to do across the South Pacific area, and we'll discuss that shortly. Just a quick update on board nominations. We currently have 5 nominees for the BICSI South Pacific board, and you'll see their names up there. We'll be posting their details on our website shortly, so you'll be able to have a look at that and then obviously cast your votes from there. Thought I'd also bring to your attention the second bullet point, that nominations are currently out for the BICSI Global Director position, and that's out this month. It closes at the end of the month, 1st of July. Note there that this is not a position on the BICSI South Pacific board, but this is on the BICSI headquarters board, headquarters in the US. The term of that position finishes up in this year, and they are currently calling for nominees for that position. Any BICSI South Pacific member can nominate for that position, and you'll see there the link to do so there. So if you'd like to discuss that or explore that a little further, either jot that down or feel free to give me a call or send me an email later on, and we'll be able to step you through that. Okay, we have for many of our seminars or webinars identified some of the free online courses. This reiterates a few of them, and we've added a few more. At BICSI Connect, there are a number of courses there that are either free or discounted. Several BICSI corporate members have approached us to let us know that they're offering free online courses, and you'll see there we've got a few listed. These are the ones that have contacted us: CommScope, Simon, Annixter, R&M, Fluke, and we really want to express our appreciation to them for making these available to us, to our members, and notifying them. And any of you who are corporate members, BICSI corporate members, and you have any free online courses or free courses, by all means let us know, and we'll let our members know. Because right now, if we're in lockdown, we've got more time up our sleeve than normal. And I should also add, I neglected to mention a little earlier, a special thank you to R&M for hosting this webinar today, and to Fluke, who host the alternate ones. This has been a challenging situation for all of us in terms of being able to continue the delivery of education. And R&M and Fluke have put their hand up and said, you're most welcome to use our webinar platform. So we are eternally grateful for them. And we thank, in this instance, we thank Craig for being around and setting it up and moderating it all for us. Just moving on, I found fascinating some information on coronavirus, particularly here, those of us here in Australia. We're dealing with a whole bunch of different legislation, different tax issues. BICSI's accountants, Mazars, have approached us with some superb webinars, free webinars that identify dealing with all the different elements of new legislation, JobKeeper, JobSeeker, tax write-offs, etc., etc. It's a maze. It's confusing and it's very complex, and there are some opportunities that are superb for organizations affected by coronavirus to take advantage of. But there are also some steps that can be very tricky. I would strongly encourage you to go to some of these webinars that they're running. You'll see the link there, and if you don't have a time to jot that down, give me a hoy and I will just simply forward the links to you. I do have their permission to forward this information on to our members so that you don't have to be their clients, you can access this information. And the same applies to the legal issues. So you'll see the next one down. Our lawyers, FCW lawyers, have just come out of the blocks. They're on the front foot with weekly 30-minute webinars looking at all different aspects of the legal elements of coronavirus, whether it's the JobKeeper, JobSeeker, standing down situation, redundancies. We do look at a number of case studies that they've gone through. They're providing some superb guidance. They do record all of their webinars, by the way, like we are, and they make them available on their website. So once again, they're absolutely fabulous information, snippets of guidance that help us to do the right thing. You don't have to be a client, you can access it. And if you need the information, just let me know and I'll forward that to you. In the AV space, both CEDIA and AVICSA have also produced a number of excellent free webinar education sessions. You'll see CEDIA is being hosted through Connected Mag and Avixa through its own website. There's some great information that I really encourage you to have a look at. Some of them are just brief 1-hour webinars, the ability to just simply get some education on a whole host of different topics, well worth having a look at. The final slide is to do with our conferences, should I say. As you're all aware, we originally had our New Zealand conference scheduled for 2 weeks ago in Auckland. That's been deferred courtesy of coronavirus. We had a tentative date of the 29th of September, but we've been in constant dialogue with the venue and our members just to get a bit of a feel for what the market is and its potential for coming restrictions coming undone later in the year. There's a lot of hesitation about it, so we have made the decision to defer it to May 2021. So effectively deferred it by a year. We're in discussions at the moment with the venue and we're looking at specific dates. And once we've got those locked in, we'll advise everyone. Likewise, the Australian conference has been deferred now to Q4 2021. It will be in Sydney. We are talking to a couple of venues and we're exploring what we can do with that. And many members would have just seen recently the announcement from BICSI head office that the fall conference, which is in Vegas, is still being held at the end of September, beginning of October, but it's being held as a hybrid conference. There will be, I guess, at the moment, the current plan is to hold it in person and have exhibition and presenters in person, but delegates can attend either in person or virtually. You'll find at that link all the details and information there. I think it also gives us the opportunity to, let's say, hedge our bets. So if the US still has lockdown by that time of the year, we can literally default the entire conference into a virtual situation. So folks can get their education from it, credential holders can get their CECs, exhibitors can do business virtually with prospective clients and interested parties. So it is uncharted water for us, but I seriously commend BICSI Global for getting on the front foot to tackle this so well. So once again, that opens up some opportunities for us in the South Pacific. If you do want to participate or attend that conference virtually, you'll be more than welcome to do so. I haven't attended a fall conference before, but I have attended their winter conferences. I expect them to be much the same, completely full of great information. So well worth getting to if you do get a chance. Have a look at that web link, or if you don't get the details, just give me a call and I can forward that to you. Well, that's the end of my presentation. I'd now like to hand over to the more important presentation to Eric Lalaurie as he discusses with us the element of 5G networks, revolution or evolution.
Awesome. Thank you very much for that, Paul. Okay, Eric.
Oh, I'm a presenter now. Stop it, Paul. You're making me blush. But thanks for the introduction. I will attempt to share the correct screen, which is not a given. Which one am I showing? I've got no idea. Am I showing the presentation?
Yes, I can see a woman with some 3D goggle things on.
All right, it's full screen now, I think. So, hi everybody, thanks for joining. I'm Eric Lalaurie. I'm the ICT discipline lead for WSV, and today I will attempt to answer the question: 5G, is it a revolution or an evolution? And people that know me probably know the answer already, but through the presentation, I will attempt to guide us through an answer basically. So what we'll do today, I'll in order to set a bit of a bit of context, I'll go back through the generations of mobile networks, and then I'll move on to 5G, how it was defined, the use cases, and then what it entails in terms of technology enhancements. A little bit on what's happening in Australia in terms of spectrums and spectrum and deployment quickly, and then some 5G statements that we see a lot, and that I'll discuss a little bit more and see what's the reality versus what's hyped, by the vendors basically. So let's start. So, if we go back to 1G, even that was not very much talked about, but 1G was basically, analog phone system made mobile. There were a few radio standards used around that. There was very early days. I don't know any of the standards. If you do, feel free to comment, but I'll quickly move on to 2G. So 2G was, really voice goes digital. So we moved on from analog system to a system where we digitized voice. We had higher capacity. The cost to end users was low, and basically that's when it became accessible to the general public. GSM was using TDMA, time division multiplexing access, which is shown in that graphic there, which basically was using the concept of time slots. So each user takes a turn to transmit and so on. So per frequency channel, per 200 kilohertz frequency channel, and I'll start my little pen highlighter. So per 200 kilohertz frequency channel, you had 8 time slots, so 8 users. If you wanted more users, you just add more channels, basically. That's it. GSM was not the only technology used. You had CDMA in the US, for instance, and other standards around the world, like in Japan and so on. Then 3G came along. So the aim of 3G was to provide data, the higher data throughput. So it was already possible with GSM, but GSM was essentially purely a voice system where they tried to add a little bit of data capacity. It shows here 28.8 kilobits per second, but with the enhancements from GPRS and Edge, you could probably reach slightly above 100 kilobits per second, but that was still wasn't very much, right? So the aim was to go up to 2 megabits per second. But 3G was really still a voice system with some enhanced data capacity. Every time you use voice on 3G, you were moving back to a circuit switch system, so purely a voice circuit switching system, like an analog PABX, more or less, to simplify. It was more efficient, you had more capacity, but that was still a voice system. And by the way, even today, or still a few years ago, before we had, that little voice VoLTE, voice over LTE icon on your phones, whenever you made a voice call with your smartphone, you were switching back to 3G. And that's why the 3G networks are still switched on today. It's because in a lot of areas where the voice over LTE is not switched on, or for people that have older phones, you're still switching to 3G to make a voice call. Whenever, when the market share of higher end smartphones and voice over LTE will be large enough, definitely the carriers will switch off 3G and we'll move on to 4G and 5G. 3G was based on WCDMA, which was a completely different technology from GSM. So it's basically using spread spectrum technology, which is spread by using scrambling codes. So I won't go into details in there. It's a bit complex. And single frequency playing. So you use the single frequency on every site, and you just differentiate the cells and the users with codes, basically, which made the planning much easier in some respect, because you just use the same frequency, the same channel everywhere, and then if you need more capacity, you just add channels, basically. Then moving on to 4G. 4G, once again, was a completely different technology. So that was LTE, long-term evolution, which we're still using today. And the underlying technology is OFDM and OFDMA. So what is OFDM? So instead of using a whole channel to yourself and one single high power carrier, right? We subdivide the channels, the radio frequency channels, into sub-frequency carriers, so smaller chunk of radio frequency spectrums, and we spread the data transmissions across these, which for a bunch of reasons makes it more efficient, more resilient, and so on. So it's a great technology. The LTE and 4G didn't stop there. It's actually using OFDMA. So what is OFDMA compared to OFDM? Well, in OFDM, if we look at that side, on the right-hand side of the slide here, OFDM basically uses the whole frequency channel per user, and then each user takes a turn, a bit like we used to do in GSM, right? That's great, but it's not really efficient, because let's say you don't need all the subcarriers to transmit the data chunk that you need to transmit, then some it's not that efficient. Some data is wasted, kind of. With OFDMA, we're able to schedule the resource so that it's always almost fully used. So we can subdivide the sub channels and attribute that to the users that need it, basically, to transmit data. So way more efficient, and that way you can use the full amount of spectrum, better spectral efficiency, if you like. LTE 4G also allowed several modes: FDD, frequency division duplex, which is basically one channel for downlink and one channel for uplink, and TDD, time division duplex, which is basically you're using only one channel, but you divide the time that you spend between uplink and downlink. And usually the ratio is 30% for uplink, 70% for downlink, because we tend to consume no data in the downlink, although that's completely configurable depending on your use case. All right, so we're back to 5G now. How was 5G defined? 5G was defined with use cases. So to give a bit of context there, and I'll show that in the next slide actually. Up to 5G, the requirements for mobile technology generations were basically defined by the ITU, the International Telecommunications Union. And they set a bunch of targets. For instance, you've got to reach 100 megabits per second, you've got to have 20 milliseconds latency, and so on. And that was the case for 2G, that was the case for 3G, and that was the case for 4G, and so on, and 5G now. But in addition to that, 5G came up with a bunch of use cases that were also the target. So it wasn't only pure, technical metrics, but also a sort of wish list of what they wanted to achieve. And that's where they started to blur the line a little bit between marketing and pure technical requirements. So if we have a look at this, basically, broadband access, being able to stream video everywhere, broadband, ubiquitous broadband access, 50 plus megabits per second everywhere. And when they mean everywhere, down to the center of the Australian bush and things like that. High-speed train mobility, so that's up to 500 kilometers per hour mobility connectivity. Massive Internet of Things, connecting any connectable object in the world via radio. Extremely real-time, reliable, life-critical communications, which are the next three. So the first one is about augmented reality, virtual reality, tactile feedback, as you can see here, which is, we're not yet there. Public safety and disaster recovery communications. And then finally, stuff like remote surgery, telehealth, and things like that, which suddenly have probably come much more real in the state of things we are now. But keep in mind, this was about 3-4 years ago, but still on the wish list. And broadcast-like services, which is basically the aim is to replace your TV and radio broadcast area. If we look at the technical side of things, so IMT Advanced was basically the 4G requirements. So that's the name that ITU gives to the 4G requirements. IMT 2020 are the 5G requirements. So these are the kind of official, standardized requirements from the ITU. And then 3G, 4G, 5G, and so on are basically the marketing flip side of it from the equipment vendors, from the 3GPP, which is the organization that creates the the radio standards for mobile technology. So if we compare, let's look at a few key metrics, technical metrics. For 4G, we had a target of peak rate, so that's per radio site, that's not per user, of 1 gigabit per second. With 5G, we want to reach 20 gigabits per second. Per user, we have 10 megabits per second, and 5G wants to achieve 100 megabits per second. Higher spectrum efficiency. So with the same amount of spectrum, you should be able to transmit 3 times more data with 5G. Better mobility, so up to 500 kilometers per hour. So I wouldn't really apply in Australia at the moment, but in Europe, Japan, and so on, that's very much relevant. Latency, that's a big one, from 10 millisecond average latency to 1 millisecond latency for ultra reliable communications. Energy efficiency, so 100 times more efficient than 4G, for instance. So these are the official targets for 5G. And keep in mind that, and I might go back on that, but keep in mind that for 4G, when 4G was first released, so the first version of 4G was nowhere near these numbers of the IMT advanced. We only came and reached them with about 2 or 3 more revisions of actually more than 5 revisions of 4G, sorry. So that which is called LTE Advanced Pro. So they keep adding names at the end of their names, yeah, just to progress the technology, basically. And we'll have a look at that in that slide, actually. So LTE, so the first release of 4G was release 8. It was first discussed in 2004, sorry, and the official release 8 was released in 2008. And the first commercial deployments started end of 2009 and basically all the way through to 2011. And then from release 8 up to release 13, these are all evolution of LTE. And somewhere in there, I think release 10 is LTE Advanced. So LTE, and forget my poor writing, LTE Advanced. And I think from release 12 or 13, it's LTE Advanced Pro. And then from release 14, we're talking about, that's where we're starting to talk about 5G, right? 5G, which is called 5G New Radio. And you might see this around, that's 5G New Radio. And each of the release basically brings improvements to the technology. So we start with, LTE 4x4 MIMO, 20 megahertz channels. And then in release 9, they added voice over LTE. That's one of the reasons it wasn't available at the beginning, because it just wasn't standardized. The technology wasn't there. Release 10 with LTE Advanced, that's where we progress with data throughput, with carrier aggregation. So instead of using a single 20 megahertz channel, we can use multiple of the channels to improve the data throughput. Higher MIMO, uplink and downlink, some more features. And then we get to release 13, we have some IoT improvements, so that's LTE-M and narrowband IoT, and I'll discuss that a bit later on. We're starting to discuss massive MIMO, which is one of the bases for 5G. And then 5G standard starts to be released, and we have the 64. So we started by 4x4 MIMO, and now that's basically 64x64 MIMO, more or less, right? That's how we started with 5G. So 5G release 14 was released, I think, in 2017. And we're right now in release 16, which is basically the enhancement of the first 5G releases. And as you can see, it keeps going, so they'll keep incrementing on that and so on. So how do we go from, 2G, 3G, 4G to 5G? How do we increase the overall throughput of a digital radio system? How do we make it better? So in terms of purely throughput, there's a few ways we can play with. We can increase the bandwidth. So GSM was only 200 kilowatts channels. 3G, 5 megahertz channels. With 4G, we had several modes. We could use from 1.4, but more commonly 3 to 5 megahertz, up to 20 megahertz channels. As I said, as I've showed on the previous slide, LTE Advanced and LTE Advanced Pro added carrier aggregation, which is basically using multiples of 20 megahertz channels. And the useful feature of that is they don't have to be contiguous next to each other, because that would be too much spectrum in one go, right? They have to, you have to share the spectrum between the multiple operators and so on. So the advantage of that is you can aggregate several channels which are potentially in several bands and improve the throughput. But with 5G new radio, we're talking up to multiples of 400 megahertz channels, which is the largest channel available at the moment with the standard. So we'll have a look at that in the next slide as well. The other thing you can do to improve the data throughput is to increase the modulation order. Again, we'll go in detail in that a little bit more. But basically, that's missing here. But we went from low order modulation, increased with edge, and LTE. I'll show you that up to 64 QAM, and 5G new radio up to 256 QAM. The other thing you can do as well is improve the number of data streams you send at the same time from the radio base station to the user. With 2G and 3G, you had no to low spatial diversity. We were not really talking about MIMO. I think it started a little bit with 3G, but it wasn't really a big thing. But with 4G, we started by 2x2 MIMO and 4x4 MIMO, and up to 8x8 in the later releases of LTE Advanced Pro, which basically, in theory, you could send up to, if we stay with 4x4, for instance, you can send up to 4 streams of data to a single user at the same time instead of 1. So you multiply your throughput by 4. And if you've seen my Wi-Fi presentation, I go through that as well in terms of how that works. And our Wi-Fi uses the same principle to send more data to devices. With 5G, we're talking about 64 by 64 MIMO. So like, just wait, it doesn't mean we're sending 64 streams of data to a single user, but it means that potentially we can use multiple stream of data to several users. So that's called multi-user MIMO. So we could use 8 times 8 streams of data to 8 different users, for instance, which improves the capacity, the overall capacity of the system. All right, so let's move on. So a bit more on bandwidth. So I was telling you about the multiple channel modes, right? And if we look at, for instance, a mid-band channel for 5G, these 5, 10, 15, 20 were the existing modes with 4G, and then we can move on up to 50 megahertz. So, more than double than the existing channel bandwidth that we used to have. Where it becomes interesting is in the 3.5 gig band to 3.7, which is basically the spectrum available for 5G in Australia. Once again, we have the older modes available, but we can go up to 100 megahertz, which is very, very good. That's 5 times the amount of bandwidth. That's great. And if we look at very high bands in the millimeter spectrum, so we're talking here in gigahertz, right? 28 gigahertz up to 79, and there's also discussions about 60 gigahertz as well for 5G. Then that's where you can use up to 400 megahertz channels. And you can aggregate those channels together. So you could use multiples of 400 megahertz to achieve higher data throughput. So there's nothing magic here, We're just adding more, we're increasing the size of the pipe basically to provide more data. That's another view on what's happening. So with LTE, if we wanted to use 100 megahertz, we had to aggregate 5 20 megahertz channels together to be able to transmit that. And because they're not necessarily contiguous and there's other requirements to be able to use an LTE channel, you had to provide a guard band around. So effectively, you know, you only could use 18 megahertz of that channel. So if you aggregate 5 times 18, you were only getting up to 90 megahertz overall of what you could use. With 5G, it's actually only one channel. So you don't have all these guard bands. You still have guard bands on either side, right? But that's only wasting about 2 megahertz. It's just an estimate, but it gives you an idea that, you know, it's much more efficient in that way to use more spectrum with 5G because you can use larger channels basically. So just a little bit, I'll start a bit here and tell you about a little secret of digital radio communications and digital systems overall. And the secret is, if you understand signal to noise ratio, you understand digital communications basically. And it's weirdly enough, a lot of people don't know about this concept or don't know enough about it, but that's all it is. Coverage, you know, and the signal received at your location is not that important if you don't have a good signal to noise ratio. So what is it? Well, you've got a baseline, which is that dotted line at the bottom, which is the noise floor. And the noise floor is not constant. It varies depending on where you are. If you are in the country, it's much lower, probably around minus 100, minus 105 dBm, because there's not a lot of human activity. There's not a lot of, you know, computer systems running around you or radio communications and so on. So the noise floor is low. And that's why radio telescopes are usually far in the country where there's nothing around, so that they have as little noise around them as possible. And in a city, typically the noise floor rises to minus 95, minus 90 dBm, depending. And then you have the useful signal, you know. So the bottom, the noise floor can vary, and then the signal level obviously varies depending on where you are in respect to your to the radio transmitter. And the difference between the two is your signal to noise ratio, and that's the important metric, right? So why is it important? So when we transmit data with digital systems, we modulate the signal to send more than just one bit at a time. There's a bit of a definition here, but a constellation diagram is basically a representation of a signal that we send over any kind of medium. So, you know, when you send data over fiber, you modulate the signal. When you send data over the radio waves, you modulate your signal as well. There's a lot of modulations, different modulations that you can use. I won't go in depth in that. That's you know, life study in itself. But basically, we started with GSM, which was using the GMSK modulation, which basically was 1 bit per symbol. It was either 0 or 1. And then with Edge, we transmitted 3 bits per symbol. So in the same duration, you're already sending 3 times more data, right? Then we move on to LTE. LTE had several modes so that it could adapt to radio conditions and the SNR. And that's QPSK, that's 2 bits per symbol, 16 QAM, 4 bits per symbol, 64 QAM, 6 bits per symbol, right? And to go back on SNR, why is it important? So you can see at the bottom here, I've got low SNR, 10 dB, QPSK. You can still differentiate the symbols, right? At 15 dB, it's very clear we know which is which. You know, that could be 0, 0, 0, 1, 1, 1, 1, 0, for instance, right? And 20 dB even neater. If we move on to 16 QAM, in the same amount of space, more or less, that's how you represent it, we've got to fit more symbols. So with low SNR, we can't see anything. We don't know which is which, right? So that's poor reception. You won't get anything through. At 15 dB SNR, you start to be able to distinguish them, and it's not great. So you might have errors, and that's where you have transmission retries and so on. And at 20 dB, it's good enough. We can make the transmission. Now, if we move to 64 QAM, which is the IS modulation order available for LTE, then at 10 dB, we can't distinguish anything. 15 dB, we can't distinguish anything. At 20 dB, we barely can distinguish the symbols, right? So that's why you need better radio conditions to be able to achieve higher data throughput. And that's basically if you understand that for digital radio communication, you're probably ahead of 95% of people that work in the field, honestly. If I look at 256 QAM that was introduced by 5G, now we have an SNR of 27 dB, which is very, very high and hard to achieve, I'm telling you. And we can see there that some symbols we can see pretty neat, but around the edge, it's noise basically. So you need higher SNR to be able to make that transmission, a minimum 32 dB, and it gets better above. So even though 5G introduces that new modulation order, in order to be able to use it successfully, you need really high SNR, which means you need really high signal and low noise. So you need low interference. And high signal means basically that you're close to the base station. So you will need to either up the transmit power, which you have limitations on. So you can only go that high, and then the ACMA tells you that's it, you only allow that. Or you've got to put more base station out there. So you need to be closer to the user, basically. And finally, in terms of increasing the number of, increasing the overall throughput, is MIMO technology. So adding more streams, spatial streams, data streams from the base station to the user, and it works the other way around as well. Now, every one of your smartphones have several antennas so that you can transmit back to the transmitter. So if we look at this, MIMO is very hard to explain. It's very complex math that I barely understand myself, to be honest. But basically the way it works is in an antenna array with multiple antenna elements, and that's a really that's a larger element, but the same principle applies for 2x2 MIMO and 4x4 MIMO and so on, is because the antenna elements are physically distant by at least half a wavelength. So there's a rule in terms of how much they need to be far apart. When they transmit data, it takes a slightly different path from the other elements, will reflect or go directly to the user in a slightly different way. With some very complex math on the receiver side of things, we're able to distinguish stream 1, 2, and 3, basically, right? So your mobile phone is able to distinguish that and recover the data stream separately, which allows us to send 3 times more data in one go in this example. Wi-Fi works exactly the same. And then you've got the other mode of that, which is MU MIMO, multi-user MIMO, where instead of sending the 3 data streams to one user, we would send, to this one and then to the third one as well. So we can split them between different users to improve the overall capacity of the system. But then you achieve a lower throughput overall, but you serve more users in one go. All right. So how does 5G achieve all of that? Well, we've got new spectrum. I'll show you a bit how it looks in the next slide. So new spectrum, more spectrum we can use, which allows us to use more bandwidth per channel and so on. We use beamforming, which allows us to do higher order MIMO, achieve higher SNR, because instead of having, and again, I'll show you that in detail in a minute, and therefore achieve higher modulation orders. And the other ones I won't talk too much about, but network slicing is basically about being able to schedule the resource and enforce things like SLAs and data capacity for a given application and a client. So you could say, police radio has a dedicated chunk of the resource, and it's not a specific frequency channel is just a chunk of the resource in the transmission that's always allocated to these guys. So that's network slicing, more or less. Number 4, it's just about, how do you transition from 4G to 5G while keeping 4G working. And finally, this one is a bit more interesting. Number 5, cloud optimized architecture is all about moving away from really dedicated hardware appliances, which is how the Ericssons and Nokia of this world created a business, really specific hardware that supports the telecommunication network, to basically software-based systems, so that you are able to deploy on any server, whether it's a virtual machine or a hardware server. So obviously the advantage of that is it opens up the market to new players, because it's easier to create software than hardware overall. It's not easy, but it's still easier. It allows for easier updates of the systems. If you need, it's not even firmware upgrade anymore. It's just a software update. You don't have to go and physically replace or repair a physical hardware appliance. You just go and, if you have an issue or if you need to update a software component, you just, check it in a new VM, and then you run that instead of the old one. Better resiliency in terms of redundant systems and so on. So it brings a lot of flexibility and future readiness to the 5G infrastructure. That's basically what I've just covered. I won't go more in detail in that, but I've put that as a reference here. So in terms of spectrum, more spectrum. So I'll start at the bottom with Wi-Fi. We all know Wi-Fi. We've got the 2.4 gigahertz band. We've got the 5.4 gigahertz band. And actually now in the US, they just released the 6 gigahertz band. So 1.2 gigahertz of additional bandwidth that is available for purely dedicated to Wi-Fi. So that's awesome, but we don't have that yet in Australia. In Europe, they will only have 600 megahertz. So hopefully we'll get it soon. Hopefully the ACMA will move pretty quickly on that one. They tend to follow the US usually for these sort of things. So hopefully we get at least 600 megahertz. But anyway, there's a chunk of spectrum for Wi-Fi. If we look at 4G LTE, so I've tried to create this more or less to scale, right? So we've got the low band, 400 megahertz to 900 megahertz, where we can use LTE. We've got the mid band, 1.8 to 2.1, and we've got the mid to high band, which is 2.6 gigahertz, which is basically what is used in Australia and most areas of the world at the moment. So you see, it's a little bit more spectrum than Wi-Fi. But if we move on to 5G, like we have 3.5 gig, 5.9 to 7, 24 to 28, 37 to 40, 64 to 71. So all of this opens up a lot more bandwidth. And with 5G as well, I haven't shown it here, but all the bands that were used for 4G and 3G are going to be able to be used as well. So there's multiple ways of doing that. You can shut down the system. So when 3G will get shut down, they will reuse that for 5G. When even if 4G is still in use, they can do spectrum sharing and share between the two technologies and so on. In saying that, you can't use any type of spectrum everywhere. Everything that's above 6 gigahertz is very good for capacity, but it's shorter range as shown here at the bottom. All right. So we would use that mostly in like dense urban centers to increase the capacity of the system. Below 1 gigahertz, we would reserve that for very wide areas, the country, rural coverage and so on. Or if we need in some areas to have indoor signal penetration and so on. Although you would rather have a dedicated indoor system, it's not always possible. So that's the answer, is to use frequency bands below 1 gigahertz. And then above 20 gigahertz, this is for very localized extra capacity. So in that case, we, like very niche applications, like really high density urban center or plaza or something like that, stadiums, conference centers, and so on, where you need very localized, super high data rates. So it's not usable everywhere. So in reality, for general coverage, you only have this available, which is still great, but it's not magic. So in terms of MIMO and improvements around the antennas and beamforming, you basically have the 4G beam here, more or less wide area coverage, right? If we look at the 5G beam, it's much narrower because we have a tighter beam, higher gain, but tighter beam. So you'd be like, but that's smaller coverage, right? Well, the way 5G works is instead of having one array or a couple of antenna arrays as shown here, you have a lot more of them, right? And this way you can transmit several beams. And what that allows you to do is provide higher SNR to your user. So you direct your beam to the user instead of covering everything. So you don't waste coverage. It's really targeted coverage, and higher gain to the in order to improve the transmission. The flip side of that is we're in the higher higher frequency spectrum, like I said, higher frequency bands, and the more you move up in a spectrum, the more you're affected by smaller objects. So above 6 gigahertz and even more above 24 gigahertz and so on, you get affected by anything, any object in the street, for instance. So all these red shadows you can see here are a simulation of how the 5G signal could be affected in the street. So you can see here very quickly that in order to cover everything in that street, you will need to have, you will need an antenna here, you might need another one here, just to cover all angles and like be able to feel those shadows, right? Even the cars are creating shadow, even people here creating a shadow. So that's the challenge with high frequency, very high frequency millimeter wave frequency in 5G. All right, what is happening in Australia? So in Australia, so far we've had the 3.6 gig band spectrum auction, which was late 2008, more or less. And we had 4 proponents that bid on that and won some of the lots. Tesla was the big winner in a way. They spent more than anyone else, 386 million. Mobile joint venture is a joint venture between Vodafone and TPG, and Optus is third. Optus probably didn't bid as much as the other guys because they have quite a fair chunk of spectrum in the 2.6 gigahertz band, so they already have some of the higher, a bit more of the higher band spectrum than the other guys. But quite interestingly, we can see here that there's a fourth proponent that's kind of new to the Australian market, Dense Air. So these guys, I don't know a lot about them, but they're basically a UK company that provides neutral hosting services. So what is neutral hosting? Neutral hosting is basically a third-party network, independent network, that is then can be used as a service by the mobile operators. So they can provide localized capacity or coverage to an area where let's say the operator doesn't want to invest in there, or all the 3 operators, a single operator, it doesn't make sense for them to invest in there. But if you would group them together, it would make more sense. Things like an hotel or a conference venue, things like that. You could provide neutral hosting, and then you approach the carriers and you say, well, this is my network, you can use it for a fee, blah, 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 and they negotiate that. The thing is, in Australia, neutral hosting has never worked or never really worked so far. And the main reason is the operators have pushed back and used every legal way possible to them to just stop any new proponent in that space. So with 5G, that might change. Got in touch with Dense Air. They said they're on hold for deployments in Australia at the moment. They're waiting for the 5G ecosystem to become a bit more mature. So they're really bidding on that 5G ecosystem. So wait and see. That could be interesting. But hopefully they're successful. I wish them success, obviously. That would be good to have another option in terms of indoor deployments and things like that. All right, let's have a look at some 5G statements that may or may not be true or very, very useful. I'll start with the first one. 5G is required for, all sorts of critical applications such as remote surgery, robots, and so on. Autonomous cars. Well, I'll start with the cars. My view on it is, yes, 5G might be very useful for autonomous cars or, semi-autonomous cars, but especially at the moment where the technology is not mature, would you really rely on an unreliable medium that can be interfered, jammed, loss of communication with the base station, and so on, to direct your car to stop because the car in front of you has stopped? No, not really, right? You want all the compute, all the processing, all the sensors to be local, so that your car can react straight away to what's surrounding it. So while it's a bonus and it can enhance autonomous cars, in my opinion, that's just what it is. Autonomous cars have to be autonomous. All the processing has to be on board, and so on. They can download extra information from 5G, and which maybe would make them smarter, avoid traffic and things like that. But in terms of local reaction, it has to be on board. So 5G not really required for autonomous cars. What about remote surgery? That's one that was hyped very much at the beginning of 5G in 2017, 2018. My view on it is a bit similar, right? Why rely on an unreliable medium that can be interfered, that has a lot of issues and no real, no real deployment examples indoors and things like that to do remote surgery? If you want to be able to do remote surgery, you need, state-of-the-art communications, and in most cases, you'd be able to bring a cable to the robot, right? The robot is fixed. It should be wired, right? Anything, and it's a radio engineer telling you that anything that's not moving should be wired if you can. So yes, there might be some very niche use cases in, disaster recovery scenarios or things like that, or an older hospital where you need to bring in an emergency surgery. I don't know. I don't even know if that makes sense, but where you might only be able to deploy 5G because obviously running new cables in an existing hospital is very difficult due to sanitization and things like that. But in most cases, these can be pre-planned, and the cable will be installed, and you'll have a much better communication link with a wired link over fiber or Ethernet, and that's what I would go for anyway. So, and remote surgery hasn't really been touted as much lately as it was at the beginning. 5G is better than Wi-Fi. I'll go over that in the next slide. 5G will kill NBN. Well, I think we're in a situation at the moment where NBN is actually coping fairly well for most people. and 5G still hasn't pushed it, on the bus. So yeah, I don't think that will ever be the case. And once again, if a connection can be wired, bring the wire to it, yeah, especially if it's fiber. 5G is required for IoT and Internet of Everything. Not really, we'll see that as well. 5G will replace 4G by 2020. Well, we're in 2020 now, it's not the case, so not really. And 5G is dangerous. So I'll cover these, I'll just move on now. I'm getting to the tail end of the presentation, by the way, so I've got about, I think, 8 slides to go. So 5G versus Wi-Fi. So I've got a bunch of use cases here, and then technologies that can be used, and we'll see if they're useful or not. So mobile coverage from, like I'm talking about mobile phone coverage in building for voice calls and data. Wi-Fi for data, yes, can be used. You can connect to your usual Wi-Fi, works very well. The experience for voice, though, is not great, right? Anyone that's used voice over Wi-Fi has had a pretty poor experience in most cases. Plus, it doesn't do roaming. So when you get from the outdoor into the building, you will get disconnected if you're on a call. 4G, 5G, well, of course, yes, that's the main use case, one of the main use cases, right? And when I say 4G, 5G, that's public telecommunication operator 4G, 5G, right? Versus private 4G, 5G. So private 4G, 5G, the main use case would be neutral host, which is the one I talked about with Dancer just before. At the moment, virtually non-existent in Australia. Right? Local area networks, well, Wi-Fi, that's the main use case, right? And with Wi-Fi 6.11ax, that will get even better. Rarely would you use mobile networks to create a sort of connect to a sort of a LAN or corporate IT. Same for private 4G, 5G, that's pretty rare. And obviously the king are cabling systems, so fiber and copper, Cat6a, and so on. IoT, yes, Wi-Fi is common. Think about smart home systems, lighting systems. A lot of lighting systems are on Wi-Fi, even commercial grade systems and so on. Mobile networks, well, it's quite common actually. Like lifts, control panels, fire panels, they often have at least a backup on 3G, 4G, and sometimes it's the primary connection as well. So yeah, pretty much used. Private 4G, 5G, that's pretty rare that you would deploy a network just for that. And then obviously, there's a range of other systems that can be used, 802.15, Bluetooth, Zigbee, and all the other variants that are out there, LoRa, Sigfox, and so on. Cabling systems, obviously, we'll see a bit of a rise in two-pair Ethernet and or single-pair Ethernet and things like that. Hopefully, I'm not saying something wrong here. Craig, correct me if needed. Industrial IoT and OT, operational technology. Yes, Wi-Fi is used, generally with some proprietary tweaks, improvements, because Wi-Fi is a bit unreliable in terms of how it schedules the transmission. Again, that will be improved with Wi-Fi 6. Mobile networks, never used. There's a use case for private 4G, 5G, but it's still very rare. That's another use case that's been really much advertised, but it's still extremely rare to deploy a 4G or 5G network for OT technology. We might see more of that. But,
Eric?
Yep.
Eric, it's Craig here. Just to butt in for a second, because there's just been a couple of questions come through. I'm not going to tell you who they're from. One is about who is currently doing 5G in Australia. I think you've covered that anyway, about Telstra, Optus, Vodafone, etc., whether they share an infrastructure.
Yep.
Yeah, I think we've covered some of that anyway. That's right. Is it? I mean, what we're seeing there is not the likes of TBG. Have they got plans in place to do it as well?
So, well, TPG, I've not followed the saga. I think they've been allowed to merge with Vodafone, right? So, because of the whole Huawei ban in Australia, TPG dropped of the mobile network race basically and declined to be the fourth operator in Australia because they were betting heavily on Huawei and their cheap technology basically, because they're much cheaper than the other guys. So they went in and started a merger with Vodafone, which they got pushed back on in the first place, but I think it was finally allowed. So Vodafone and TPG are basically bundling together to propose network services, and Vodafone will probably keep on doing the radio side of things, and TPG will bring on the wired side of things, I suppose.
Okay, that makes sense. And then actually, just back on the slide you were on just a moment ago, sorry.
Yep.
About catering for 5G coverage within inside of a building.
Yep. So I've got another slide on indoor coverage for 5G. So if the question is about that, I'll detail that.
It is, yeah. Okay, so you cover that afterwards. And then the last question was the NCF guidelines.
Yep.
When and if will they be updated to cover 5G?
So I'll discuss that in the same slide in a couple of slides.
There you go. You see, the system works. Thanks, mate.
Yes, great. All right, keep going. I'll just move on because I'm starting to get a bit late. Internet of Things. That's 5G is required for Internet of Things. Well, not really, because the improvements to Internet of Things connectivity actually been proposed in releases before 5G. And what's been done? Well, typically that's a 5 megahertz 4G channel, and we can go up to 20 megahertz. But that's not ideal for IoT, because larger channel means larger power consumption, larger cost, and so on. So there's two standards for IoT in the mobile world: Cat-M, LTE Cat-M, which specifies 1.4 megahertz channels, so lower resource use, lower power consumption, lower cost, and so on, and lower spectrum use, obviously. So that's one enhancement. And then the next level is NB-IoT, which goes down to 200 kilohertz. And if you remember from the earlier slides, 200 kilohertz is exactly the channel bandwidth of GSM. And the point is to be able to fit in one NB-IoT channel in between existing GSM channels for countries that still use GSM, because you still have countries using GSM. So again, even lower cost, even lower power consumption, and so on, and even lower resource use. And obviously that's for lower data application, long range, low data for those sensors you have out in the field. So NB-IoT competes directly with the likes of LoRa, Sigfox, and so on. And that's been there for a few years. Tesla started releasing NB-IoT, so you can do NB-IoT on the Tesla network, I think since 2018 or at least 2019 for sure. So no, I could put tens of these pretty pictures that I stole from somewhere from Google saying 5G, but in reality what they're using is this, right? So just don't get fooled. 5G might improve some of these things in terms of being able to schedule the resource a bit more efficiently, but overall, that's what we're using at the moment. So we don't really need 5G to do IoT or industrial OT and so on. Might improve, but it's not required. 5G will replace 4G. Well, in 2020, we still mostly using 4G. On the left-hand side, these are the phones available to Australia, the 5G phones. I think definitely Tesla and actually I don't know, Tesla for sure as 5G enabled base stations. They've just released the news saying that they've started upgrading their base station to 5G standalone, which means at the moment to be able to connect to 5G you need a 4G connection. That's 5G not standalone. 5G standalone means if you only have a a 5G chipset, you will be able to connect to the base station. So we don't have 5G standalone mobiles, as far as I know, and Tesla predicts we'll have them by the end of the year. And this is the list available globally. So there's a few more, but it's not a huge amount more, right? So it's still not very widespread, still kind of high-end smartphones, right? They're not cheap and so on. They're $1,000 plus the Samsung ones, for instance. So it's still not accessible to everybody. It will take a few years before that's the case, right? Just like for everything. 5G safety, that's a big subject. You might have seen the news in UK, people burning base stations thinking they're 5G, so they've burned 4G base stations by mistake, are harassing radio staff and so on. So it's pretty, especially in that in the wake of the coronavirus, all the conspiracy theories have ramped up significantly. And obviously 5G, which was always in the eye of these people, is right in there. So I'm not an expert in that field, but basically, we have the visible spectrum, which is the light we see around you. That's how we see stuff. Everything below that, and a little bit above, but everything below that is classified as non-ionizing radiation. So these radiations don't cause cancer, right? They don't cause mutation in your DNA. That's what ionizing means, more or less, right? So everything you're using in there, the only effect it has is heat, right? So when you go up a building on a rooftop and you see those warning signs around the mobile cell antenna, they say, don't get close if you're not trained and if they're not shut down and so on. You still have to be careful about that, because if you get close to the antenna, you have that heat effect, and basically you get burnt inside. But it's not causing mutations. But it's still dangerous, but it's not causing mutations. But as you can see here, only 5 to 10 meters away from the antenna, you're already dropping 50 dB in terms of power. And 50 dB in terms of wattage is 100,000 times less. Sorry, 50 goes up to minus 20. So it's 100,000 times less than the original transmission. So the radio energy goes down very quickly. So again, not an issue. In addition, for higher frequency bands, your skin acts as a barrier and blocks the radio signal from entering your body at all. So actually, the higher you go in that range here, from 6 gigahertz and above, your skin acts as a barrier as well and will block the signal. So it's even less. The heat effect of the transmission is even lower than these transmissions in the lower bands, which were FM radio, TV, and so on. And finally, there's been no study conclusive of any, carcinogenic effect on humans for radio transmissions. So far we're good, but of course you can choose to believe the conspiracy theories. So that's one that's been quite popular about coronavirus and 5G. I'll let you read about that one. All right, let's move on. In buildings. So in buildings, at the moment in Australia, we only have 5G allowed in the 3.5, 3.6 gigahertz spectrum. In an existing building with an existing distributed antenna system, this frequency range wouldn't be supported by the cabling system. So as your signal travels down coaxial cable down to the splitters and the antennas, it would get attenuated too much to work reliably on an existing system. So 5G as we know it today in Australia wouldn't work on that system. The only way to deploy 5G would be to deploy small cells, so like active access points, 5G access points in the ceiling. And I'll show you that on the next slide. What's likely to happen is as we shut down 3G, the operators will just remove the 3G equipment and they'll bring in 5G base stations, and these will be compatible with the lower frequency range. So for instance, I don't know, 1800 megahertz. And then they'll put 5G in it and they can transmit 5G at 1800 megahertz over the DAS system. And effectively, this 5G replacement will be very close to 4G, so it won't be an issue. The only thing that they might want is to have MIMO antennas instead of SISO antennas in the ceiling, but even that, not a massive issue. So that's one way to deploy 5G in buildings, is wait for the lower bands to be available in Australia for 5G, and then just replace the base station, connect them to the existing system. So, existing building or even new building that's being built now, that's what I would recommend most likely. If we really want to move to a truly 5G in higher band system, the only way at the moment would be to deploy those sort of 5G access points. So these are universal access points that can, in theory, be shared between multiple operators. They have multiple antennas embedded there. They're sort of like a mini base station. That's what a small cell is. And to deploy them, you either need fiber or Cat6a or Cat8, if Craig manages to sell you that, to connect to it, back to a sort of a network. Might be a proprietary network, might be just a dedicated LAN for the small cell system. And then you will deploy them in the ceiling. And I think the standard, what is it? 11, come on, help me, Craig or Paul, 11.8 something, .6. I'm not very good with my standards.
11801.6.
I was almost there. All right. So
that Paul really doesn't. You don't know that, Eric. Honestly, I'm sideways about that.
So I would rely on that for future provisions in terms of using the service outlets that are described in that standard, and that which are there for that purpose, for instance, right? And Craig, no comments, please. That's the only way you can sort of future-proof your or make your building future-ready for these deployments, basically. But that's taking a risk. For now, my opinion is stay on the traditional DAS system, and we'll see in a few years. About the MCF, well, about the MCF says basically almost nothing about that. The MCF was released in 2018 after about 3 years of 2-3 years of consultation with the industry. It took a very long time to update from the 2014 version. And the MCF just says you can try to make your DAS 5G ready, but we don't think 3.5 gigahertz will work on it. So it's not really a hard requirement, basically. So they're not asking you to be 5G ready in the MCF. And at the moment in Australia, no telco is deploying 5G in buildings, none at all. They don't have the gear, they don't have the equipment, they don't have they don't want to deploy 5G indoors. It will come, and again, what form? With it a replacement of the 3G base stations in lower bands, or is it this universal 5G access point small cell? Who knows? Wait and see, basically. And I wouldn't wait for the next MCF revision, because that might be 2025, or we shall see. So I don't know if you followed me, but basically my opinion is that 5G is not a revolution. There was a lot of hype around 5G and everything it could achieve and solve the world, issues and everything. But really, 5G is just an incremental evolution of the existing radio standards. It's building on 4G, it's improving 4G, it's providing more spectrum and more capacity, and that's the main use case. It's providing more capacity. Then the side use cases, which potentially will come to fruition, but it might take 5-10 years or plus. These might only be realized when 6G gets released, for instance. Who knows? So my opinion is that 5G is just an evolution of the previous standards. It's great, it's needed, but it's not magic, right? It's not going to solve all the problems we have with wireless communications. It's not going to solve all the issues we have with those use cases magically. Most of the coverage will be achieved by technology that is very close to the current 4G. So in the lower bands, 2.6 gig and below, 5G, it will be called 5G, but it will be very similar to the 4G we know today. And 4G will stay as a blanket coverage for quite a few years still, probably 5-10 years at a minimum. Yeah, so that's basically it. I want to, I wanted to kind of bring that critical view on 5G. Beware of the vendors. Vendors are always going to try to sell the next brand new technology because they need to kickstart the next spending cycle. Investment in 4G now is very low, and they need to try to sell gear and move on to the next generation, basically. That applies to any industry, possible. Wi-Fi, the same. Vendors are always going to try to sell you the Wi-Fi 6 access point, even though they still have the 802.11ac access points available. If you want to go further on 5G, I've noticed there's been quite a few. There was a talk actually yesterday, I think, on Wi-Fi and 5G on BICSI, which I missed because I had a meeting, unfortunately. But there's quite a few things on BICSI Academy that are close to 5G or on the 5G subject, and DAS and so on. There's a really good book, quite technical, but the first few chapters are quite high level. I've taken quite a few. You might have seen the attribution, but I've taken a few of the graphics from there. 5G technology, 3GPP new radio. That's basically the reference if you want to learn about 5G. And then online resources. I take quite a lot of inspiration from a very well-known analyst called Disruptive Dean, which again brings that critical view of the telecommunication world. So don't hesitate to have a look on Twitter. A lot of telco and Wi-Fi people are on Twitter for some reason. So if you want to see the news and things like that, it's a good idea to be on Twitter. And then you can follow these links as well for some online resources. There's a lot more out there, of course, but it's some of the ones I follow regularly. And that's it for me. 1 hour and 6 minutes. Not bad.
Well, that's awesome. Thank you very much, Eric, for that. A whole bunch of information through there that you can confidently rattle off your tongue, but it's certainly left me with some questions to go and find out, I think, separately, because there's quite a lot of development in the whole RF space, but I think you've done a good question despite such an advocate. So you've done a good session despite being such an advocate for RF technologies to kind of reinforce the point that it's not some sort of utopia or panacea as a one-size-all replacement for other network types. So I'm just looking at the question pane here. If there are any other questions, could you just tap them in now, please? If not, like I say, feel free to reach out to BICSI or to Eric or myself after the session if something crops into your mind and you've thought of something you'd like to ask after the fact. Paul, you still there?
Yep, still here.
There we go. So I'm just going to hand it over to you just to say thanks and wrap up, I think. So just thanks to everyone from my side of things. Next time I won't make the admin error with the timings, rest assured, but thank you from my side of things, and I'll just hand it over to Paul to close it out.
Okay, thanks very much for that, Craig. Look, firstly, I just wanted to say thank you to Eric for a very stimulating discussion. I love the fact that we've demystified so much hype that's kicking around about 5G, and you've told it in the plain truth with all the technology behind it to back up your statement. So certainly appreciated that. I'm sure all of us have walked away learning a great deal and getting a better, clearer picture of the rollout and deployment of 5G, which is inevitable, but as you pointed out, it's not the magic wand. And perhaps in 5 years' time, we'll look back and go, 5G is so boring compared to 6G. So this is just the march of technology. Also wanted to thank Craig and RM for facilitating this webinar today. It was great that we're able to do it on a platform that's robust. It was able to communicate the information. We've had members from, I believe, as far east as New Zealand and as far west as Japan. We've got a number of members in Japan who've joined us. I hope you've been able to glean some information from that. We've got folk all the way across Australia. So we've got quite a broad range of people. We do thank you for your involvement, your attention. Apologies for the muck up with the timing. We will go back and ensure that it is always going to be at 11 a.m. Australian Eastern Time. What's that make it? 1 p.m. in New Zealand, 9 a.m. in WA, and 9 a.m. in Japan. Now, just a bit of a quick comment about the next presentation we have. We have my apologies for the phone ringing in the background there. We do have Peter Greaves from Oricon. He's their global head of future buildings, so quite a visionary man. He's spoken at our conference once before. Peter is talking about the building of the future in 2 weeks' time. Pardon me, that's the 2nd of February. Sorry, let me rephrase that, the 2nd of June. And that's at 11 a.m. Australian Eastern Standard Time. So we'll send an invitation to you for that, and we hope that we'll be able to share some information. And by all means, please keep the questions coming, and we do appreciate the engagement that we've been able to have with the industry. So thank you very much.
Thanks, Paul.
Thank you, everyone. I'm going to close the session now.
All right, thanks everyone. And if you have any questions, you can reach me on LinkedIn or ask Craig or Paul my email. Thank you.
Thanks, mate. Have a good day, everyone. Bye now.